This is the third and final video for estimating large numbers. The section here deals with not enough numbers. It talks about trying to estimate the number of telephone numbers that exist within the United States during certain periods of time. The counting principle is the major topic or major concept that is to be addressed in this unit. The counting principle simply says that for the number of options in event A and the number of options in event B, you multiply the options for A times the options for B, and that gives you the total possible combinations of those two events happening one after the other. The next thing we have is finding the number of options in a range. So a couple different examples. Let's say we have 5 to 20 and 18 to 100. Well, we need to find out how many numbers are from 5 to 20. Most of the kids will simply just subtract these numbers. Well, in order to find how many numbers or the number of options in this range, we not only have to find the difference, but then we have to add 1 to it. So if we take 20 minus 5, most students will say that's 15 options. But what they're forgetting is that we start with 5, and 5 is a valid option. So we have to then add that 5 back. So there are 16 options in this range of numbers from 5 to 20. From 18 to 100, again, you subtract 100 minus 18, and that's going to give you 82. But then you have to add 1 more, and there are 83 options of numbers in this range. So you need to be able to find the number of options within a specific range. And then restrictions. Every range of numbers or every telephone number, every system of numbers has certain restrictions. The telephone numbers restriction helps to prevent 911 or dialing 911 before you start dialing the rest of the 10-digit number. So there are restrictions that you have to take into consideration, and then you have to remove those restrictions from your counting principle estimation in order to get a relatively accurate estimation of how many numbers you're trying to search for. So focusing on this example here, we have this telephone number in the United States. NYZ is the area code. ABC XXXX is the 7-digit number assigned to every area code. So we have the rules for each digit in this telephone number. We're not going to look at NYZ because the first part of this worksheet has you look at NYZ. We're going to look at the 7-digit number. So one area code has this many, the answer we're going to come up with, has this many 7-digit telephone numbers available inside of a single area code. So here we have ABC XXXX. That is 7 different events that happen in order to create one 7-digit number. So our counting principle is going to have 7 events that we have to find the options for each one of those things. So first we have A. A can be any number from 2 to 9. B, C, and X can be any number from 0 to 9. And then we have some restrictions. There's more restrictions on the worksheet, but I just want to come up with this one. B and C cannot both be equal to 1. So we have to account for these restrictions whenever we get our answer with what A, B, C, and X can equal. So here, 2 to 9, if you subtract those, you get 7. But remember, you got to add 1. So that's 8 possible digits for the position of A. And then 0 to 9, it looks like 9 numbers. Most people will think it's 9 numbers, or most students will, but it's actually 10 digits. And so the way I like to do it, I like to line the number up to the letter that it can be. So A can be 8 digits, B can be 10, C can be 10, X, 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 and X. Those can all each be 10 digits. And then the counting principle says we need to multiply these 7 numbers. Well, if you take 10 times 10, 6 times, that's 1,000,000. And 8 times 1,000,000 is 8 million 7-digit telephone numbers inside of a single area code. Well, then we have to look at our restrictions. B and C cannot both be equal to 1. So if we take our 7-digit number, and now the only restriction here is that B and C are both equal to 1. Well, A can still be 2 to 9, so that's 8 digits. X, 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 those can all still be 10. And again, here we have the counting principle. Here I've restricted B and C to both being 1 at the same time. So we multiply these 7 events again to get the number of restrictions. And we have 8 times 1 times 1. Well, that's just 8 times 10 to the 4th power. Well, 10 to the 4th power is 10,000. 8 times 10,000 is 80,000. So we have these restrictions. These are numbers that cannot exist. So we have to take this 80,000 and subtract it away from this 8 million. And so the number of 7-digit phone numbers that exist inside of a single area code based on these rules is 7 million, looks like 920,000. And so that's how you use the counting principle with this type of situation. There are several other examples where you're going to be asking about zip codes that exist, and you can even come up with a few more if you know some numbering systems, and then you can make up your own rules and restrictions, and then you can extend beyond what the worksheet or what the AQR curriculum has you teach.